So in terms of examination, there are two types of examination that we're going to do: individual exercise and also project presentation. So the individual exercise will not be necessary if you're going to do the project on your own. But if you're in a group of 2 or more, then you need to do the individual exercise. So there will be on LESAM, you will be able to book yourself in for 2 different blocks. So obviously we'll see how this goes in terms of the current situation, if you can sit in the university and do the individual exercise, or if you have to solve it in another way. We'll see about that. But we're going to do the planning as this is, and then we'll see if we have to change it in the future. And here are some more information that you can read regarding the individual exercise. For grade 3, there's going to be basic knowledge that we're going to test. Grade 4 is going to be more advanced knowledge, so more design automation knowledge, and then grade 5 will be even more so. So there are going to be uploaded a couple of previous individual exercises that you can see how they actually look like, so that will give you an idea of how an individual exercise actually looks like. Project presentation. So the group presentations is going to be 4th and 5th of June. Here we can also book a time in LESAM. And here we really want to just understand how you have done and what is the logic behind your project, and so on and so forth. So each group will have a 5-minute presentation, and then we're going to have a discussion for 15 minutes. Well, we'll see how the actual how this will be done. If it's going to be done remotely, then hopefully you have CATIA already open in your computer. These details we can also take more on Teams, which will be the main tool for us to communicate. So here you can read through the requirements for grade 3. So just click pause and read through the grade requirements for 3. And then here you have requirements for grade 4. And then lastly, grade 5. And here is a summary of all the requirements. We also put in the best results on our blog. Here is an article that Leo Press did on a couple of students who did like the best project 2 years back. And actually Olle, who is furthest to I don't know exactly how the orientation will be now. So it's hard to say if it's left or right. But it's the guy who is sitting down, who has a gray shirt. He's actually working at our division. Really bright guy, really happy to have him on our team. And the others are actually have worked with design automation related master theses, which were also really awesome. Okay, so this is the course plan, and so the weeks on the y-axis is not correct. It should start with week 14. That will be corrected in the material on LESAM. But we start with week 14, and I hope that we can somewhat try to keep this this pace. So basically, we work with a basic part of the course in 2 weeks, and then the advanced part of the course where you work with parametric Lego, Excel interface, and then introduction to Power Copy, which is the actual design automation part. That is 1, 2, 3 weeks. After that, I hope that you can start working with your examination project, where I personally think you do the most of the learning there, because doing tutorials is good, but it's not great. So when you start with the project and you really need to think outside the box, maybe you can even come back to the tutorials and learn some more. But try to have a good pace with the tutorials and then start the project as soon as possible. So there will be a couple of compendiums that we will upload, which you can browse through. These are not without mistakes. I mean, there are a lot of small error, not errors in the sense where it's completely wrong, but I mean misspelling and stuff like that. They're definitely not perfect, and that's why you don't need to pay for them. So it's just it's compendiums for free, so you can just download them and read through. Hopefully there will be good help for you together with the tutorials. The tutorials, on the other hand, they're quite good. Also some small mistakes in the tutorials, but nothing major. So the examination project is going to be project-based learning. So you learn by doing a specific type of project. And the goal is create a reusable and flexible model of a complex engineering product. Okay, so the course material, I've mentioned this before, we have a basic compendium which will help you with the tutorials that are listed here. And then here is some basics about the first tutorial, which is very, very basic, a lot of pages. And for the next tutorial, it will be easier or less number of pages because you understand the principles more. Then you will use a workbench which is called generative shape design in order to create flexible parametric surfaces. This is a very good tutorial in order to understand how surfaces work in CATIA, in order to understand the whole how to connect the different surfaces and guiding lines together in order to get smooth transitions and so on. And then you have a select any design product to surface model in the generative shape design workbench again. So here you choose something that you think is interesting. And then there is a tutorial which is for wing assembly tutorial. And for the advanced compendium, we have removed a couple of tutorials because they are actually inside the course E-TMKT57, the multidisciplinary optimization course. And here there are two types of automation methods that we are using. One is called morphological parameterization. This is just to change the shape of a geometry by applying either parameterization, mathematics-based parameterization, or script-based relation. You can change the shape of a geometry. It's kind of like a dope. Then you have topological parameterization. This is where you can start doing really, really advanced stuff, especially when you mix the topological and morphological and topological parameterization, because then you can take a feature which can, upon placement we call instantiation, placing it into the specific context, it takes the shape of that specific context, and then you can do really interesting things actually. So here is like Lego. It's a typical topological thing. Some products are good to model with morphological thinking, and some with topological thinking. So Death Star obviously is better with Lego than with Dough, and morphological is not so good if you have like some kind of a shape that you want to alter. If you try to do it with topological parameterization, then it's a hassle. Then morphological parameterization is much better. The first tutorial is called Parametric Lego. Here you do one Lego model, which then can take different type of shapes depending on a set of rules that you will define. This is a really good tutorial to dive into the whole design automation domain, I would say. And a lot of companies working with design automation are not more advanced than what this tutorial actually teach. So when you take this step, then you're already at a really high level of state of practice in terms of industry, at least. But then we have the Excel interface, which basically you combine the parametric Lego with connecting it to an Excel interface, and you can change the parameters in Excel. And then we have two tutorials. One is Introduction to Power Copy, and one is Planetary Gearbox. The Introduction to Power Copy is here we do the whole topological parameterization the advanced topological parameterization. That is actually enough. You don't need to do Planetary Gearbox. You can look through the Planetary Gearbox, just look through the codes and the tutorial, but you don't actually need to do it. If you really want to do it, then do it, but it's not necessary. Yeah, that was my last slide. So yeah, I like to automate, and as you have understood by now, hopefully, and obviously, I really do believe that you should never send a human to do a machine's job. That's a given. But it is also very important to never send a machine to do a human's job. We shouldn't fall in love too much with these type of techniques, because they shouldn't take over. Because they can't, to be completely honest, at least not right now. There are some things that humans do much better than machines do, and if we try to exclude humans and engineers, then you will completely fail. That will not be a good way of going forward. So if you want to be successful in this field, you should know and understand the balance between automation and manual engineering. So try to keep a perfect balance, then you will be successful. Thank you for watching this video, and I really hope that we can have a really good course together. Take care. Bye.